Hey there, ladies and gents. This is another little design idea. It's a radial vandergraph. Like traditional vandergraphs. I have to choose that one there, this one. Well, like a normal vandergraph, you'd have the lower wheel or pulley and then the upper pulley. Normally this would be going straight to a cone, but the cone actually goes in from the other side. It will be a drive motor for the belt that zigzags inside and out, and these are going through this material. Now, the construction is you've got obviously the metal dome, or possibly this could be a flat plate. Got the orange here, which represents a copper or conductive material. The grey, which is a metal, or it could be copper again. I should have probably done this copper just to make clear. But this will go through the insulator. Now this insulator would either be like a rubber or in whichever other material is a pretty good insulator. It doesn't have to obviously be this thick, but again, depending on how powerful the overall thing is, it may have to be thicker or such. And this is like a side view of the cross section of the radial vandergraph. Now, going back to this one where the mouse is, this is the motor. It is connected to one of the inner wheels, or maybe it could be connected to one of the outer wheels. It's up to you, I guess. Which is represented here as well on the left of the mouse. But again, so all it is a vandergraph pretty much on its side, and having a continuous belt going around, all in the same direction. So obviously when the side goes up, it goes back round, comes down, goes back up, down, up, down, up, down. Basically giving you, with this design anyway, 6 vandergraphs in one system. Obviously, yes, putting it on its side takes the space too, but you know, it's just not as tall, and it may serve the advantage of having more than one vandergraph going to the same dome, which might actually give you, I don't know, a higher current or a higher current electron flow. Given that most vandergraphs are high voltage, but they're also just one. This one has six connected in parallel. And again, I don't know what the output is. So we'll try and get a better angle. That's pretty good. That's pretty much it. You got the inner core here, which would normally be the base. This would be the base of the vandergraph. That's usually going off to Earth, I believe. Or it would be connected to another line, which would, you'd spark them together basically. That's what you want to do. This, the green lead would be connected to Earth, which would go to the central hub, which would normally be the base, and it would just brush past the electrodes sticking out and carry the electrons up, pass them on to the next one, the next set of electrodes, which will charge the top dome as a vandergraph does, and then the belt will come down as neutral. It will come back down to the electrodes and charge up again, just going back and forth all the way around. I've seen with some vandergraphs you have to have like a nylon or a substance, not sure what it is, but usually in the actual in the belt, like to separate as conductance, but that's pretty much, you can do that by putting a material either side or wrapped around the actual belt, so that it touches electrodes on the bottom side, and on the other side of the belt it will touch it on the other side. So that's the idea for a radial vandergraph, giving you possibly a higher current or not, or just good voltage, or a standardized vandergraph. But that's the design. Well, thanks for watching. Any comments, please leave them back in the comments section. Right guys, see you later and take care.